What happened?
Okay, so that would cause
There it
x
is.
minus 2. That's x minus 2. You put 3 times 2
All right, let's see what happens. It should kick in a little brighter here in a second, but can somebody... Oh, good. I'm in. Can you turn off the one that says... Let's just turn one back on. We're scared. Okay. Turn the other one back on. Now turn the other one back off. Yeah. There you go. All right, good. All right, so here we go. Oh, that's good. All right. So I understand fractions are very few people's best friends. I wish I really knew why. I think it's because we don't use fractions much. But you use them more than you think. I mean, in simple ways, like half of 20. You know what half of 20 is, but you just did 1/2 times 20. That's what you just did. The whole idea, like here, can I add 4x and 7y? Can I add 4x to 7y? Hell no, because of course you need like terms. So I think you're getting ahead. So if I add 4/5 plus 7/10, that is like 4x's plus 7y's. That is 4/5 plus 7/10. They're not like terms. So if you make them both over 10, now you've made them like terms. So if I multiply by 2, I get 8/10 plus 7/10 is 15/10, right? Not 15/20, not 15/100s, do weird stuff like that. So that's why I need LCD, because it's just like terms, exact same thing. But can I do, what is x plus xy? Can I add those?
No.
Hell no. What is x times xy?
X squared.
So you can multiply when they're not like terms exactly, right? So that's why when you have fractions, you don't need LCD when you multiply or divide, because you don't. Right? You can do stuff when addition subtraction needs LCD, because you're trying to combine like things. That's what I'm doing when I'm adding, or I'm taking away like things when I'm subtracting. How are we doing so far? I mean, that's the basic thing about fractions and why we have to do what we do with them. So, and then, this also has a little bit of this. So let's talk about order operations. Who knows something about order operations? PEMDAS, and I hate this. And there are actually teachers that teach you do multiplication before division, which is pure bullshit, right? The only reason we have it, we could have written it like this. Totally, all day, we could have written it like that. Which one's easier to say? First one. Second one, you sound drunk. Right? You guys understand? Because you could do multiplication division, you do it as it comes. Addition subtraction, you do it as it comes. If you didn't, if I have $7 and I owe you 10, and then I find a $20 bill on the pavement, I should be able to pay you off and have money left over, right? But if you add first, you get 7 minus 30. I owe $23 to somebody. I don't know who. Do you guys understand what I'm saying? It's just the same thing with multiplication division. If I have 4 divided by 4 times 4, this is not 4 divided by 16. Right? And a really good way to look at this is, how do I rewrite 4 divided by 4? There's another way to write 4 divided by 4. 4 over 4. Where's this times 4 go? It goes here. How would it sneak down there? How would that 4 sneak down there and become 16? Do you guys understand what I'm saying? It's not fair to divide by 16. It's not being divided by, it's being divided by freaking 4. So the right answer here would be 4 divided by 4 is 1 times 4 is 4. Alright. So I'd much rather, I hate writing it in a straight line, I'd much rather write it like this, because I'm weird. Definitely parentheses, definitely exponents. Either one of these is to come, either one of these is to come. That's the correct way to write PEMDAS. Right? And it's please excuse my dumbass son. Or dear Aunt Sally. Whichever one sticks in your head. I always have somebody's got son that's like, that'll stick in my head. What I think every morning. Those of you with sons, I don't know if you agree with it. I am a son, so that has happened. Alright, so coming back to this. So, mixed numbers are a little bit, no, I don't want that. Mixed numbers are a little bit weird to work with, sort of like this. Get out of there. return. This is exciting. Yeah, where are you, that button? Oh, this is awesome. I love that casting this one, do you? Oh, Scheisse. Oh, no, I've just lost everything. Oh, there it is. Okay. Let's see. Get out. Where's the out button? Let's see. I don't see the button anywhere. No. That's the one. Okay. There's got to be one. Did it get out? No. I don't want to do those settings. Oh my God.
I would just go to that.
To 10 down.
It says that you're currently on it anyways.
That's what I was trying to do. Let's see. It won't let me go all the way.
Yeah,
There it is.
yeah.
All right, it wouldn't let me do that. All right, save and exit. Oh, that was exciting. Holy crap. All right. So, mixed numbers make subtraction and addition a little bit weird because you can get top heavy in the fraction piece and all this weird stuff. So, a really good idea is to convert the mixed numbers into improper fractions, right? So, how do I do that? 3 1/5, how would I make that into an improper? 5 times 3 plus 1. 16/5. Real quick, anybody know why that works? You ready? Yes, sir. Go ahead.
I know why it works.
Cool. Tell me.
Because you have 3 whole numbers, so that would be having like 5 5s. It would be 3.
I know where you're going. All right, so you got it. This sucks. This notation sucks. What you're saying is right. 3 1/5 is not 3 times 1/5, right? This is 3 and 1. This is 3 plus 1/5.
How we can recognize it?
If they mean 3 times 1/5,
Yeah, because
they would put
sometimes
parentheses.
and I thought just that it's multiplied. It is not
If they wanted multiplication, they'd have to do that. Or at the very least, this, which is even still bad. They would have to put parentheses to indicate multiplication.
So wouldn't you multiply 3 times 5 and add 1?
Of course. We just said that, but I want to explain why that's true.
Okay.
So everybody agree that 3 1/5 is the same thing as 3 plus 1/5. All right, so something we sort of forget sometimes. How do I add these fractions? And of course, the denominator is going to be that. So I'd do 5 times 3, wouldn't I? And then I would add 1. So 5 times 3 plus 1 is a shortcut of what you would do if you wrote what it meant. You guys got it with me? So it's so much better to understand why you do something than just to know what to do. And of course, some guys are like, well, it's better to know what to do than not know. I agree. But it's so much better even beyond that to understand why you're doing it. Everything that we do in math has to make sense. It has to. It has to. Or else we got to throw this shit out. And you're like, throw it on. No. So then this guy becomes, 29 tenths. I still got this other stuff here. Now I need common denominator times 2 times 2. So I get 32 just to kind of conserve space. This is 32 tenths minus 29 tenths, which is 3 tenths. And when I divide, is everybody cool with that first part? When I divide, how do I divide fractions? Multiply by the reciprocal.
Yeah.
Real quick, you guys should know where that goal is. Why? Why do we do that?
Because it's division.
But here's why. If I had, guys, just bear with me. Right, if you don't like me explaining everything, it's too damn bad. You got to rough 3 weeks. If I had 2/5 divided by 4/9, and just stay with me. I'm going to do some weird shit that you should never do. This explains why this works. Right? Go with me. Can't I write that? You would never do this. You would never do this. But couldn't I write that as 2/5 divided by 4/9?
No.
Hell yes, I could, right? And yes, I do write that down. Sorry. That's another reason you got to have a rough 3 weeks. How can I make the bottom 1? What would I have a big ass fraction, right? With little ass fractions inside. How do I make the bottom? I can multiply top and bottom by whatever I want to. Is that true? What do I multiply by to make the bottom become 1? Yeah, they're reciprocal. 9/4. So I multiply by 9/4. So now this equals this. And what's the bottom?
1.
1. So this equals this. Bam. That's why you multiply by the reciprocal, because that's... I don't know if you ever got shown that, or somebody just told you, multiply by something, because that's how it works. Well, screw that shit. You got to know why it works that way. Otherwise, you're not going to make it very far in math. If you don't understand why that works, you're not going to be able to build on it. Right? So does everybody kind of get that idea? I know you guys can do it, and you've done it a million times. But it's so much better if you know why you're doing it. Right? All right, and then what's the last thing I could do here? Or the second to last thing?
You could lower it, 3 divided by 3.
Good. I could multiply, but it's better to reduce now while all the numbers are smaller, right? Then it goes into 20 twice, so I get 2 over 11. So if you got 2 over 11, good start. If you didn't, can you see where you made a mistake? All right, I like it. Cool. So that's the first one. Second. Here comes, this is just blatant PEMDAS. Does PEMDAS ever go away? Hell no. It's always there. It's not just in section whatever. It's the grammar of math, which is why it sucks. What's the hardest thing to learn about a different language? Vocabulary you can just do, but the grammar of a different language is really hard. If any of you guys know a second language, you know. Especially if English is your second language, congratulations. Right? Because English is really stupid. We got all kinds of shit going on. Right? Oh, well, you guys don't know what I mean? Maybe? You're anti-English. No, it's just a weird-ass language. I grew up in it, so I can almost speak it.
Can I have another one, Matt?
Yes.
I wrote like really messy in there. Thank you.
Let's see. So, first thing I want to do here. PEMDAS. First thing is parentheses. You cannot distribute this. You can't. And I really want this, again, I want this to make sense. Like, are we ever going to finish problem? If it was 3 times this, could I distribute the 3?
Yes.
Hell yes. Right? Because multiplication is based on addition, which is the same thing really as subtraction, believe it or not. So, coefficients are beautiful for distributing across addition subtraction problems. So if I had 4 times x plus 7, of course I can bring that through. But if I had x plus 7 to the 4th, I cannot bring that through because what are exponents based on? What property or what operation? Multiplication. So if this was 7x to the 4th power, then I could distribute the 4 all day. Why? Because inside there's the operation that it's based on. Why am I able to distribute this? Because inside there's the operation that it's based on. Because exponents don't play well with addition subtraction because they're not based on addition subtraction. So good God, I would have to multiply. I have to write this 3 times and multiply it out. But why would I do all that shit? I know what negative 1 minus 2 is. What is negative 1 minus 2?
3.
Okay, cool. I like it. And why didn't I do 3 minus 5? Because it doesn't say 3 minus 5. It says 3 minus all that shit. I've got to figure out what that shit is first. So the very last thing I'm going to do in this problem is the subtraction. Because that's at the end of PEMDAS, right? The AS. So what's the next thing I do? I do the parentheses. Exponents. What's negative 3 cubed? Negative 27. Why is it negative? If I have 3 negatives, 2 of them cancel. Let me do the right one so I don't flick you guys off. 2 cancel, 1's left. It's still negative, right? 3 negatives is still negative. But now what happens? The most common mistake is people will get 27. But again, that's not fair. I'm not divided by 27. I'm only divided by 9. I do multiplication and division as it comes. So I take negative 5 times negative 27 is...
185.
What kind of 135? Positive. So 3 plus 135 divided by 9 times 3. How do I know that 135 is divisible by 9? Don't tell me because you did it and it worked. If I just look at 135, does anybody know how to tell it's divisible by 9?
Oh, because you added.
They add up to 9. I love it. So few people know that anymore nowadays. 1 plus 3 plus 5 is 9. If they add up to any multiple of 9 in any digit, the whole thing is divisible by 9. People don't know that anymore. If the last 2 numbers, if I make this big-ass number, 4, 7, 2, 9, 7, 6, 6, 8, 5, 5, 2, 4. the last two digits are divisible by 4, right?
Yeah.
So the whole damn thing is divisible by 4. Bang! But people don't know that because high school says, oh, we got calculators now. Well, screw that. You should know it as a human. Oh, my God. Anyway, sorry. I have strong feelings, obviously, about this very stuff. Oh, we're not done here. So what is 135 divided by 9?
Yeah, 15.
15, all right, so 3 plus 15 times 3. What do I do next?
15 times 3.
Good, 15 times 3.
45.
45.
3 plus 3.
So you get 48. So we got 48 good. If you didn't, make sure you can tell where you went wrong. And don't do that again.
Just one question. On our stages, I mean, like printers, I mean, multiply first and later on division. Why we didn't do 9 by 3?
So again, it's let's see if we can find some space in here. So if I have you do 8 divided by 4 times 3.
Yeah.
Right? How do I rewrite? What's another way to write that? It's the exact same instructions, it just looks different. How do you write 8 divided by 4 in a different way? 8 over 4. That's 8. That's what this is right there, right? 8 divided by 4 is 8 over 4. Now, how do you write times 3? Where would you put it? Next to it. Not on the bottom. Why would it go on the bottom? There's nothing there that tells you have to put it on the bottom. It's that piece times 3, right? So you see, now you could do 8 times 3 or something, but you got 8 divided by 4 is 2, times 3 is 6. Not 8 divided by 12. That's not right. Because then you somehow brought the 3 down. What's the only thing on the bottom in that whole problem?
4.
The 4. If you do 4 times 3, now you've got 12 on the bottom. How did you do that? It's not quite, an amazing thing. But it's like, how the hell did you do that? All right, maybe. You guys some guys are looking at me like, dude, man, it's first
So
day.
even though division and multiplication is done first, because the division's up there first, you do the division part first, then the multiplication.
Multiplication division, you do it as it comes.
As it comes.
Totally.
Right.
That'll keep that, if you do that, it'll make sure that you don't bring stuff to the bottom that aren't supposed to be there. Now, there are shortcuts. The more comfortable you are with order operations, there are shortcuts. But you always got to show me work. I almost wore my show my work day shirt today. But I reserved that for a test day, just to remind you. But I have a shirt that says show your freaking work. It doesn't say freaking. It says show your work. So obviously it's important. All right? Don't tell me, I just did it in my head. Well, that's great. Capture some of that. Write it down so I know where it came from. I'm not knocking you. If you do a line in your head, that's awesome. But as a teacher, I can't get in there. Right? Open your head up. Can't do that. That would be so awesome. That'd be weird. Actually, that's weird image. So this guy, I hate FOIL. Don't get me wrong. If you like FOIL, if it helps you, it's awesome. It's totally unnecessary. And then FOIL, this isn't FOIL. This is there's a middle term. So it's just take the 2x and distribute it. Take the 3 and distribute it. You don't need FOIL. You just distribute each piece. So what does FOIL mean? Who knows what FOIL means?
First, outside, inside, left.
So what do you get if I multiply, if I take the x and distribute it? What do? I take the x times x.
Yeah.
That's the first 2. And then I take the x times 5. That's the outside for the O. I don't need FOIL. I just distribute each piece. Now, don't get me wrong. Use FOIL all day long. It's great. But you should have never been taught it. It makes it seem like it's harder. You're like, I need a mnemonic device. Because no, it's not. You just distribute each piece. And then if I make this guy bigger, like I did here, who cares? Right? FOIL's shit now. FOIL doesn't have first out or in or last. What the hell? No, I just distribute each piece. So what's 2x times 4x squared?
8x squared.
8x
3.
cubed. Good. And then 2x times negative 6x. Oops, sorry guys. Let me know when you can't see that. I'm not used to this. Negative 12x squared. And then 2x times 9
Or 18x.
plus 18x. Now you take the 3. Now it's the 3's turn. Right? 3 times 4x squared.
Plus 12
I'm going to line up my like terms. 3 times negative 6x.
minus 18x
And then 3 times 9.
plus 87.
So you get 8x cubed, and then these cancel. They won't always cancel. I just made it so they would. If you remember cubes, I set that up so that it was in the right order to become a cube problem at the end. This is sum of cubes. Bam. Sum of 3. Continue to become 3. There you go. So that is a sum of cubes, and that's how you would factor it. I just wanted you to go the other way to prove it. I call it, now watch.
But do you make that then the 3 cube, the 27, do you cube that to reduce it 1?
Yeah, this is simplified. If you made a 3 cube, that's unsimplified. So the instructions, when they say simplify, you want to do all the operations. Yeah. If I did factor this, break ax cubed into 3 parts. 2x, 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 right? So 1, 2x there, the other 2, 2x is there. 27 is 3 times 2 times 3. 1, 3 there, the other 2 3's there. Do you see that? And the middle term is what I call the Pulp Fiction dude. Let me say that correctly. The Pulp Fiction dude. Anybody ever seen Pulp Fiction? If you haven't, you probably should. Just go through it. It just gets a little bit gory, but that's all right. There's a whole scene, just for an example of goriness, where they shoot the poor guy in the back seat, and they call the dude, what was this, the wolf? Is that what it's called? The cleanup guy. The cleanup guy. So the middle term, this is the cleanup guy. It's what gave us these that killed these. It cleans up the shit I don't want. So 1 of each in the little dude, 2 of each in the big dude, and the middle guy is 3 times 2x is 6x. That's the cleanup dude. It's what's going to kill all the shit you don't want. I like it. Maybe. I will do more factoring later, but I just want to talk about that while I was there. This guy was interesting. Now, real quick, when you divide, what do you do with powers? You subtract. So for example, a to the negative 6 divided by a7 would be negative 6 minus 7. What's negative 6 minus 7?
Or 1.
Negative 6 minus 7.
Oh, it's
Negative 13.
Negative 13, right? Because I owe $6, I owe $7. Unfortunately, you can't cancel debt with each other. I wish I could. That would have made the time after grad school so much easier for me. I had like $30,000 in debt. Yeah. The day I paid it off, I'm like, oh my God. Negative 6 minus 7 is negative 13, and then you would flip them down, right? A to the negative 13 wants to flip. I'm like, why do all that weird shit? Flip the negative 6 already, so you don't make negative mistakes. You don't get a 1. Those 6 A's, what's the only things in here that want to flip? The 6 A's and the 7 B's. Everything else stays right where they are. So, first off, how do you reduce the 24 and 40?
3/5.
Yeah, 8 goes into both. Then you got these 7 A's, and then these 6 A's are coming down with them. You got these 7 B's that are here, right? Those 7 B's. And what about the B to the negative 7? They're going to come up. Now, this is not the only way to do this problem, but this is the way I highly recommend you do it. Because what's 2 of the worst things in math? Negatives and 0. If I can control them, I will, right? So if I can make the negatives go away, yes, right? So I can make them go away by doing what they want. They want to flip. So now what do I have on the top?
B14.
B14. A13. I like it. And just to check, what is 7 minus negative 7? 7 minus negative 7 is 7 plus 7 is freaking 14. What we just got in an easier way, right? Maybe. So you guys look bored, which is good. If you already have your own way to do this stuff, and you're like, oh, beautiful. Keep doing it the way you do it. Kick ass. Before I get too far, 2 things. Let me show you why negative power means flip. Right? I don't know if you were ever showed this or just told where I'm from. Actually, I do know where I'm from. How do I set this up? All right, let me remind you guys. If I have x to the 5th over x to the 3rd, what would that be? X squared, right? Is that cool? All right, so if I have x cubed on the bottom, what do I put on the top so it comes out to be this? Why do we get a 2 there? Because 5 minus 3 is 2. So what I'm asking you really is, what minus 3 is negative 1?
X2.
Careful, 4 minus 3 is positive 1.
X2?
X2, okay, right? Is that cool? So that's true. What I just wrote here is true, right? All right, I like it. You guys are smart. Now watch, what's another way to look at this? Isn't this x times x over x times x times x? How many x's cancel? 2. How many are left? Where? So these are the same. Those are the same, because that's... You guys see that? No, some of you guys are like, oh, what you just did. It isn't even impressive, because I don't even know what that is. I did this problem one way, and I got this. I did it a different way, and I got this. Therefore, those must be the same thing, right? So negative power means flip. And how do I lose, if I wanted to lose an x, if I had x to the 6, what can I do to it to make me have one less x?
Minus x.
I can divide by x, right? Is that cool? I can divide by x.
To be minus, yeah.
Or I can multiply by x to the negative 1. Because what do I do with the powers?
Yeah.
What do I do with those powers? Add them. 6 plus negative 1 is 5. So 1 over x and x to the negative 1 act the same way. They both take x's away. That's why negative powers mean flip. I like it. Yes, sir.
Oh, why didn't you cancel out the 7s attached to the b's?
Oh, alright, you're going to love this. You're going to love what I'm about to say. This problem has no 7s in it. And you're like, alright, I got to leave because this guy has meds he was supposed to take. Because there's 3 7s in. There's no 7s in there. Does anybody understand what I mean by that? There are no 7s in that part D. There are none. What does that 7 mean? That there are 7 B's. I don't know if this is helping answer your question. I can't kill the 7s because I'm not dividing 7s. I'm dividing 7 B's by somehow negative 7 B's, right? That's why I flip, because the negative power is weird. So I flip it to make it positive. Now it makes more sense.
Okay.
Maybe. I'm going to say that every now and again. I'll say something like, there is no 2, and there's a 2 right there. What do you mean there's no 2? Is this Matrix shit? 2 million. No? Okay. Sorry. No Matrix lovers? The first movie was good at least? Alright. Yeah, there you go. Sorry. Alright. And then on the heels of this, where was I? Let's do it here. What would I put on the bottom to make it come out to be this? X cubed divided by what would be x to the 0? Yeah, the same thing, right? Because then 3 minus 3 is 0, right? But what is something divided by itself? 1. So x to the 0 is 1. All right. Anything to the 0 power is 1. Except 0 to the 0 is weird. It's not even undefined. It's what's called indeterminate. And we'll let that stay that. We won't talk about that anymore. This is weird. Where am I? There I am. All right. So let's come back here. So what's 3 to the 0? 1. What's being raised to the 0 power here? Just this piece. So it's minus 2 times, and what's negative 2 to the 0? 1. So what's 1 minus 2?
1.
Negative 1. There it is. Cool.
Wait, what? Hang on a second.
So what's 3 to the 0?
I got that 1.
Alright, so 3 to the 0. Let me do it over here. There we go. 3 to the 0 is 1.
Yeah.
Minus 2, because the 2 isn't, nothing's happening to this 2, right?
Right.
Yeah.
But what's negative 2 to the 0?
1.
Times
So
1.
it didn't matter if it's a negative or not. It's just still, it's always going to be
Anything
1.
to the 0 power is
1.
1. So what's Jeff to the 0 power?
1.
1. What's negative 4 square root of pi to the 0 power? 1. I don't care how freaky or what the hell the inside is. As long as it's not 0, anything to the 0 power is 1. Done. Don't say there's a negative. No, who cares? It's 1. And another way to look at that. Oh God, Jeff. Please no, Jeff. It's too bad. What's x divided by x? 1. All right, now watch. So if I start with x cubed, let me see if I can do this. What am I trying to say? Yeah. What's another way to say that? Screw it. There's a way to do it. Oh, why is it 1? Because these cancel. Where's the 1 coming from? That's a weird question, I know. But there's always an understood 1 in front, right?
Yeah.
So if I take all the x's away, if I have no x's, the only thing left
1.
is that 1. So x to the 0 means no x's. So what's the only thing I have then if I have no x's? 1. So there's another kind of way to figure out that x to the 0 is 1. You're just left with that understood 1. Alright. I got to think that through. It just came to me. So what about this guy? What's nice about this problem, F? There's a nice thing about it. They're fractions, but they already have LCD. So I know the answer is going to be over what? And then on the top, I just have to add them, right? So 3x plus 2 minus x, put your like terms together.
2x plus 2.
And then you always have to, when you get a fraction answer, you always have to see if it reduces. And the way to reduce, you have to do factoring. Right? You can only cancel something if it's the opposite operation. This always is weird to me. I know I keep doing this. Sorry. Can you do anything with this directly?
No.
Why not? Why can't you kill those x's?
Because it's a whole factor.
It is not multiply.
Because division is not the opposite of addition. It's that simple. You can only cancel stuff if you have opposite operations occurring, right? So if I add x times y over x, what can I do? I can kill those because that's division's job, is to kill multiplication, right? This is my job. I'm here to kill. I don't even know what that was. Sorry. I just finally we saw Terminator Genesis when I went to a conference, and there was a fire in the theater, so we had to leave like halfway through the movie. And I finally saw the rest of it. It was like a year ago I started watching whatever. Hey, sorry.
So you didn't miss lunch?
No, but it was still, you just turn your brain off and it was awesome. What do you got on the top here when you factor?
2x plus 2.
X plus 1. So the x plus 1's cancel. I like it. So you just get 2. So that's kind of interesting. If you think about it, no matter what you make x, 2 is the answer. Except what's the only thing x cannot be in this problem? What's the only thing? There's one number that x cannot be. -1, because that makes the bottom 0. There you go. So the only x you're not allowed to use is -1. Any other x you put in there, I don't care what x, put in there square root of 11. You get 2. That's what that means. I like it. Cool. You guys, you look like you've been through math class. Alright, so I start off nice on 2a. Right? Obviously, we should all know how to solve equations. That's the last thing you do in Math 88 and then Math 90. There's just equations every damn where. So you should have equations down pretty good. So how do I do this? Yeah, distribute first. Now here's where everybody makes a mistake. Or not everybody, because a lot of you guys did this beautifully. But I always get somebody telling me that's a -12. What have I done wrong? Yeah. Why is it plus 12? I'm distributing a -3, right? So I like this. Some of you guys did this. Say again?
I was the same time -4.
Yeah, so that you could rewrite -3 as plus -3. So then you can really see it's -3 times and then -3. So then 2 negatives make a positive 12. Cool. And now I just have to get my like terms together, right? Do the same old stuff. Oh, now make it a plus, Jeff, like you just said. And then this is x plus 4. Like it? And then you just got to get your x's on one side, numbers on the other side. You should all know how to do this. So I get 2x equals 6, x is 3. Bam. Bam. And you can plug the 3 in. Is that cool? I finished quickly, but...
Yeah.
Alright, I like it. Alright. And then part B. Here's the way I teach this. And the reason I teach it this way is it would help us for that problem there. And we will get there. Very quickly, very soon. Well, every damn thing we do in this class will happen very quickly. What I recommend is to make the bottoms the same first, because it's a process we're used to. You could multiply by 12 and reduce, but it actually helps us out later if we start to think of it. What does this guy need, of course?
2.
4. To make it 12. The LCD is 12, right? What does this guy need? 2. So now I get 8x over 12 minus 10 over 12 equals x plus 7 over 12. Everything's being divided by 12. It's an equation, so what am I allowed to do in an equation? I can multiply both sides by, in this case, 12. And that kills all my fractions. Multiply by 12 everywhere. Die, die, die. So then I get 8x minus 10 equals x plus 7. And then I'm going to do this a little quickly. Subtract x, add 10, divide by 7. So you get 17 over 7. So that's just reminding you that answers don't have to come out nice. If you get 23 over 49, it doesn't mean it's wrong. It just means it doesn't. Too bad.
So the 12 cancels out completely?
Yeah, if I multiply both sides of 12, it cancels. In fact, it's better to write them next to each one of them. Then you can really see a 12, 12 all cancel. Right? If I make all the bottoms the same and then multiply by that bottom, they all die. What's the only thing that allowed me to multiply by 12? No. Why was I allowed to multiply by 12? Equal sign. It's an equation. It's got two sides to it, so I can keep it balanced. Maybe. I can't just say, I got 1/5 of $1 and then multiply by 5 and make $1, right? There's no equation there. I can't. Too bad for me. Look at this. 1/5 of $1. No, right? It's a little beyond my ability.
When because it's 8x take away 10 equals x plus 7, and then it's 7x equals 17. So when you move that 10 over to the 7, it automatically turns into a positive?
No. A better way to look at it is, I want to make it not here. How do I undo minus 10? Add 10.
Oh, okay.
So again, a lot of people think when you move it to the other side, it becomes the opposite sign, and that actually will work. But it's one step away from why that's true. Why not just do why it's true? We want to kill the numbers on one side and make them show up on the other side and the other way for the x's. I like it. Okay, cool. So number 3, there are two main ways to do number 3. What's one way somebody did number 3?
Plug 0 in for y.
I like it. So some of you guys found the intercepts. You plug 0 in for x to get the y-intercept and so forth. And some of you guys, I actually watched you...
Y equals mx plus
y equals mx plus b. So let's do both. Here we go. Let's do the intercepts one first. So if I plug a 0 in for x, what do I get for y? 3. If I plug a 0 in for y,
2.
yeah, I get divide by 3, I get 2. I plot those, and I'm done.
Yay! Wait, really?
Yeah, dude. Or do that.
That's easier.
I like it. In this case, it was easier. Obviously, 3 and 2 go into 6, so the whole thing was nice. If it was 11x plus 17y equals 49, I might not want to do the problem at all, but too bad. Now, the other way to do this, so the other way, go away, is to solve for y, because that forces it to be in a y equals mx plus b form, right? So to solve this for y, I subtract? Yeah, I gathered here together. But we got 2 more. Alright. Princess Bride? No. Subtract the 3x, and then, of course, divide by 2. So you get y equals negative 3 halves x plus 3. Now, y is 3, the y-intercept. Y is 3, the y-intercept. Because when you make x 0, you get 3. So in the equation mx plus b, when you make x 0, you always get whatever the hell b is. That's why b is defined to be the y-intercept, because it is. M is the, I always call it the amplifier.
Slope.
So if it was like a 2, if x changed by 1, y is going to change by twice that. And that's all about how much it runs and how much it rises. That's why those are related to each other. That was my Math 90 full day lecture I just did in 10 seconds, sorry. But you should know this coming in. You should know this. So I can start I always got to start on the line so I can plot my y-intercept. And then the slope will always get me back to the line. It's sort of like hiking, and you get off the trail, and then you can always get back to the trail if I use the slope or whatever. Right, if you hike in a straight line. It's a horrible example, but too bad. So negative 3 over 2, I'm going to fall 3. Now the big mistake is people go back 2. They're not both negative. 3 and 2 are not both negative, or it would have been a positive. They would have canceled. So you fall 3 and you run 2 in the positive direction. And thank God, if I would have just drawn that right, let's just make that big. I get the same answer both ways. Yay, yay. Just one of them has a really big neck. Right. Alright. So how's that? You should know both ways, because it could ask you to do either way I want to. Cool. But pretty much, let's see. Alright, so let's do this. The rest of the class I want to focus on factoring, right? So, let's transition to the board. We'll talk about some ideas and then we'll do these problems. Who's back there? Somebody back there turn the light back on? All right. So I'm not going to get too in depth. You gotta, in general, what I always say when I'm teaching in math classes, if I'm going too fast, slow me down. If I'm going too slow, deal with it. All right. So, please, dear God, you got to speak up. If you got a question, at least 10 other people have the same question. They're just shy. You could be their hero, if just for one day. Oh, if you try the problem, see me after. I'll let you know if you got it right. I don't even know the answer yet. I have to work it out. So factoring, the most basic form of factoring is, and what I call step 0, is GCF. Right? Do you always try GCF first?
Are we keeping this?
Yeah. Oh yeah,
Okay.
that's yours.
I was going to write on the back. So.
You got it. You can write wherever you want to on that bad boy. So for example, all right, start off nice. How do you factor this?
Reduce the 4 and 12. Reduce the 4 and 12. And reduce.
You don't say it like that. I can't lose anything.
No, reduce. Okay.
Take it out.
Take it out.
Because that's what's common, right? Number-wise, I can take a 4 out, and letter-wise, I can take one x out. Why don't I take 2 x's out?
It's not 2 and a half.
Because this poor little dude only has 1. So it's sort of like the fair tax man, right? You only take as much as you can give. You don't take more. Mr. Taxman, I ain't got that much. So you take 1 x out. See how I moved? Now, real quick, these are little tiny things. But see how I put that over? So this answer goes here, this answer goes here. Be nice to yourself, right? The way you organize your work will affect the way you do it. So what's left here? If we take a 4 out, it's gone.
X.
I got 1 x left.
3.
Good, beautiful. And then check yourself. You can always just multiply back in. Make sure you get the right answer. The same thing you started with. I like it. Everybody should be able to do that, no problem. One little weird thing. Let's try this. What you got, Jeff? I don't know, man. Alright, that'll work. Cool. Alright, so something weird, something a little bit weird happens here. So what comes out?
Is that 45
Yeah, is
or
that
4S?
45 or
45, yeah. What does that look like?
the
4S.
Oh. Yeah, 5 is a bad number for me. Good luck to you, by the way, as far as reading my handwriting is not so bad that I can't read it myself. I had a teacher once that if you asked him what he wrote up here, he's like, "Do we remember what I wrote up here?" Because he couldn't read his own writing. The day that happens, I retire. I'm out. Right? I can't read that to people. So I can still read my own writing, thank God. So what number comes out? So it's got to come out of all 3 of them. I like it. So 3 comes out. And then put it over a little bit. How many A's can I take out?
1 A.
So the shortcut there is the lowest power you see, right? So that's the one that everybody has. And how many B's come out?
2.
2. So then what's left here?
3.
Yeah, 3 is left.
And then
B.
3 A, B.
Yeah,
Yeah,
1A,
B.
right? And then 1B. I like it. Minus
15.
15. That's gone.
B2.
B squared. The big mistake is like if people do that. People do that because they think, oh, I took that out. It's gone. But why is this 15? Because 45 divided by 3 is 15. So what is this divided by itself? 1. Yes. That's the weird thing that happens there. And because if you stopped here, do you get everything back? Where does this guy come from? So this is like a placeholder for him, right? That's another way to look at it. It's a placeholder. I like it. So GCF should be easy. Then the next level is grouping, right? It's basically GCF, just a little bit weirder. Does this sound familiar? You do this with 4 or more terms. I like it. So you got something like this. Yeah, there's one. Don't use 5, Jeff. Too late. Or 3. Where is it? Let's see. All right. That's part 8.
Now, when you do it on a test, are you gonna say a certain way we need to factor it? Or
No, not normally. I
Okay.
might, but normally there's a big section just.
factor. Okay.
Yeah. But this is really one way to do this one. Why can't I do something at all?
Why can you
So
not?
what you,
Why can't I do something? Now, real quick, let me show you this. Does everybody got this here?
Yeah.
Look at this problem here. Look at this problem. How do I factor this? What do you mean?
just keep B out.
Pull a B out, right? So
Yeah.
they both have a B. That's the same problem as that. Those are the exact same problem. Because here they both have this. Here they both have this. So 5n minus 3 is one thing. If n was 1, this would be the number 2. It's one thing, isn't it? They both have it. So you can take it out. So if I take out 5n minus 3, what am I left with?
7x plus 3.
Yeah, 7x plus 3. Alright, so most of you guys should be cool with that. In fact, some of you guys might have wrote it the other way, and why is that okay? Because multiplication, I don't care. 2 times 4 is the same thing as 4 times 2. I don't care if you put that first. Cool. I like it.
Oh, I see it. I got it.
You got it? Cool. I like it. So if I get this, so that's just to work up towards grouping. So that's sort of like just straight up GCF. So what if I had this problem here? Oh, I got to make it work, don't I? Let's see if I can do that. In my brain. That's scary, Jeff. Oh, this will work out. Okay. Yeah, let's do this. Okay. Don't be too evil to yourself. I almost require, but I'll end up just strongly recommending that you do not draw parentheses in. That's what screws you over. Right? So when you group, there's 4 or more terms. Just underline. Why do I do that? Because when you draw parentheses in, you actually took a negative out. And then that'll screw up your signs if you're not careful. So there are 4 terms. I can group them 2 by 2. What can I take out of this? Who do what?
Why?
Why? Okay. Now, what do I know has got to be true about this thing here?
It has to be the same.
Has to be the same as this. So what do I take out of negative 8x to make it positive 4x? Not 2. 2 won't work. Negative 2. I love some of you guys are like, 2 is the same as negative. No, it ain't.
But then you just bring down the minus anyway?
But see, don't look at it like that. Because if you look at it like you're taking a negative 2 out, then what's going to happen to both of these signs? You're going to change. So if you're not careful and you put this down, again, that's a 5. Do you guys see the mistake? What mistake did I make? Yeah, I didn't make it negative. I kept it positive there, right? I should have changed negative because I took a negative out. Are you guys with me?
Mm-hmm.
If I did that, I should not be able to do the next step. But people always do the next step. I'm like, how did you do it? Are these the same? So there isn't anything you could do. So thankfully, this is supposed to be a minus. Right? What's 10 divided by negative 2? Negative 5. Now these are the same. Now I can do like we just did up there. Yes, ma'am.
Did you bring that minus down?
No, I took a negative 2 out.
Okay.
So, I mean, you could look at it like I took a negative down, but it's more than that because that sign's got to change because I took a negative 2 out of that.
So does the negative belong to the 8?
In a way. But when I take a number out of both of these, it ends up belonging to both of them. Because I'd have to distribute this back to both of them then, right? So it's all about the way what you do next. It's what that negative goes with, right? All right, maybe. So what about if you have 3 terms? So the 0 step is GCF. The first step is grouping. If there's 4 or more terms. So what do you have? 3 terms. So 3 terms could start off nice. Let's see. You can do it, John. Oh yeah, it was gross. Look at that. Yeah. It's yummy. Now watch this. This is what I don't understand. Little side. Let's do an easy one real quick. That one's a little bit gross because of the 320, right? But just make sure everybody's on the same page about how to think about these things. How do I factor this here?
Put X in each one and.
Good. X squared is X times X.
That's 5.
Yeah, and you factor the 10, that makes 7, 5, and 2. Is everybody with me on that idea? Right? And of course, you should also know why that's true, because I know that whatever these two numbers are, they're going to multiply to this, and whatever they are, they have to add to be this, because I would FOIL it, right? Using the horrible word, but oh. Okay. So here, I need two numbers that multiply me negative 320 and add to be negative 4. Say again? No. Thanks for playing. No, watch. You ready? This is what I don't understand. I need two numbers that do two things. Who cares which one they do first? What do I mean? Normally you start with factors of this. You don't have to. Why don't I start with numbers that add to be negative 4? What kind of numbers are they going to be, though? Are they going to be the same sign? They're going to be multiplied negative, so they're going to be different signs. Mm-hmm. So like 10 and 6, if the 10 is negative, don't they make negative 4? Do they also multiply to be negative 320? No. Okay, so keep going. This is much easier. This is like a Price is Right game. This is negative 60, right? When you multiply, that's too small. Well, let me make my numbers bigger. What about something else that's 4 apart? Negative 14 and 10, right? Do you guys see what I'm doing? If you don't, you can still break 320 up and do the factoring thing, but how many factors does 320 have? A lot. So I want to go higher, right? I want to get to 320. So what's negative 14 times 10, though? It's only negative 140. But you see why it's like a Price is Right? I'm getting closer, right?
16 and 12.
All right, 16 and 12. Something else to realize is it ends in 0, right? But let's see what this is. Negative 16 times 12, what's that?
It's going to hit a 2 already.
Nobody has a calculator? 192, right? I better know. Yeah, let me just show off. Yes?
So does the answer negative 18 and 14?
No. Well, it's been said twice. It has to end in 0, doesn't it?
20 by 16.
Yes, 20 and 16. That makes negative 320, right?
Yeah.
So I don't know if you understand what I just did, because everybody here knows you need two numbers that multiply to be this and add to be this. My point is, who cares which one they do first? Why do we always start with this? I don't know. You don't have to. If you want to, cool. This is just one more option. So what does all this stuff mean? What's the answer?
X minus 20. X plus 16.
Kick ass. I like it. So that relates to the first problem on that factoring piece of the handout. That guy. Yes.
So what if there's a different one?
Can't be.
No, I'm saying like,
Oh,
if the whole
a different problem.
was different. Yeah.
Yeah.
What if it was minus